Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program, brought to you by TechStrong and Chronosphere. My name is Cody J. Brown. I'm the host of TechStrong Learning, and we have an exciting program ahead. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and we really hope that you do, we want you to send those in to us using the Q&A tab. You can find that tab on the right side of your screen, along with a few other options. The next one will be the chat tab, and that's where we want you to get to know your fellow audience members. Let us know your thoughts throughout today's program, or maybe just from where you're tuning in. We'll also have a couple of polls that we'll be running throughout today's program, so we do want your attendance, or your participation rather, there. And we do have a couple of handouts available for you under the Handouts tab, so feel free to download those additional resources at your own leisure. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of today's program. So on to the topic. Today we'll be discussing distributed tracing doesn't have to suck. And I'm joined today by Ian Smith, Field CTO at Chronosphere, and April Yep, Senior Product Marketing Manager at Chronosphere. April, Ian, thank you both so much for joining me today. Would you like to take it from here?
Thanks, Cody.
Definitely. Thank you, Cody. Good morning, good afternoon, and good evening. I'll just kick us off with the agenda. So today we're going to talk about what's happening with distributed tracing, why distributed tracing tools suck, why we want distributed tracing, and how we can improve distributed tracing. What's happening with distributed tracing today? First and foremost, metrics and logs has been seen as the de facto way to know, triage, and understand a problem, which is not always the best. Next slide. But wait, in the world of going from monolith to microservices, how do we do this? There's a lot of questions of using metrics and logs. Then when you're going to microservices, it's really changed how we work. Next slide. But is the job being done right with just metrics and logs? And let me rephrase. Let's just throw in traces to metrics and logs. And so, okay, now with microservices, everything's getting done right. It's all of it's in place now, right? Just throwing in tracing? Not exactly. Next slide. So it doesn't seem like things are getting better. And maybe Ian wants to talk about some of these points specifically because he's experienced these a lot and had a lot of conversations with different folks on how like MTTR is going up, and there's been a large amount of staff churn. Hours spent on incidents is going up. The observability costs are going up, but engineer productivity has been going down. Utilization of tracing has decreased to less than ideal levels, and reliability and uptime are down.
Yeah, thanks, April. Obviously, we all had this great white hope that we could just sort of like apply distributed tracing on top of the existing metrics, logs, maybe even APM that we were using before as we move to these microservice environments. With the factors that you see here, though, I'm sure there's a lot of resonance for people who've undertaken these efforts. Maybe not all of these things have popped up yet, but in the conversations that we've had across the industry, there's definitely a pain points where certain things you want to be improving are actually getting worse or going higher, and things you want to maintain a high level of are actually plummeting. And it's important to think about this sort of in a broader sense. It's not just, hey, are we meeting an SLA? Do we have distributed tracing? Do we have the fanciest features out there? It really needs to be focused on these outcomes and things that ultimately observability tooling needs to be serving us.
Thanks, Ian. So what sucks about distributed tracing? First, let's talk about the implementations and outcomes that distributed tracing has not met. the first point I'll make here is it's been designed for power users. This means that people who are experts in the actual tool are the ones who adopt it and get the most value, versus a casual user is less likely to spend their time daddling around in a tracing tool and figuring out how things are working. And
Yeah.
talk about your own experience with this.
Yeah, and this can sort of present itself in some insidious ways. Most engineering organizations have those advanced or experienced engineers who oftentimes get pulled into incidents to help solve problems. And particularly as you move to microservices, if your tooling around distributed tracing is too orientated to those power users, you're going to deal with the fact that those power users get brought in on every single incident. They're getting woken up all the time. And often those engineers are the ones that you're really relying upon to drive innovation and huge progress in your organization. On the other side of things, you probably have a much larger contingent of developers who want to be effective, particularly if they're on call, and are constantly stymied by the fact that the tooling is just too dense and too problematic when they're in the middle of an incident to be able to pick up easily and just get up and go. And so you get this sort of disaffected audiences of both your power users and your general developers, because the power users feel like they have to be there all the time, and the general developers feel like they're really not able to solve the problems that they should be able to, particularly in today's modern world of if you ship it, then you own it, and that DevOps mentality.
The second point that we want to make is visibility. There's a push towards heavy sampling, which creates a lack of confidence in the data quality.
Yeah, and the last thing you want as an engineer working at an organization that's invested all this time and effort in deploying distributed tracing, doing the instrumentation, deploying tooling, whether it's open source or vendor solution, is to have that nagging sensation that, hey, I can't find the thing that I know is there. I generated an error, but I can't see the trace that has an error. Maybe it's because of sampling, maybe it's because of my pipeline. But oftentimes people sort of wave this approach of, well, sampling is used at the largest organizations, so it should be a really effective way for us to treat our tracing data here. But unfortunately, the moment you start to erode that confidence in the data because of sampling, then you're in this position of like, okay, well, I'm not going to use this because I don't trust it. I'm going to go back to the things that I know and I trust. And so you get even less adoption and less investment happening with this pretty expensive tooling.
The next point we want to make is that a lot of these tools it's a tracing first thought process, and the platforms that specialize in tracing limit the power associated with context mapping.
Yeah, it's really important to consider what were we doing before tracing, and this is something we're going to dig into a lot more in this particular webinar. But if you have sort of tracing off to the side and isolated by itself, you're constantly having to re-perform the investigation. If you get an alert that's based off metrics, and then you have to hop over to tracing and then start from scratch, then you're losing a lot of effective time, particularly during an incident investigation, that could be avoided if you were focused on really connecting those experiences together and making sure that tracing isn't just a silo that's slapped on top of your metrics, logs, and APM, as we showed before.
The next point to make is ownership. Service owners are not stakeholders in the collection and lack ownership and control.
Yeah, this is really tied into instrumentation, particularly as you have lots of dependencies, you have various owners downstream who maybe aren't invested in providing really good instrumentation so that you, as someone who's upstream, can understand what's happening with your services. A lot of this comes from older styles of instrumentation, say, for example, agent-based instrumentation, where simply just dropping an agent was enough to get you the visibility, and you sort of treated observability and monitoring as a checkbox. Okay, I've deployed the agent, that's all I need to do. But realistically, flexibility does come with a higher level of investment, but also payoff. So getting an understanding of exactly what insights that you might need and then implementing that in your instrumentation and owning that yourself is becoming definitely a key cornerstone of things like using open source instrumentation standards like OpenTelemetry.
So just to quickly recap, we've seen that it's been designed for power users. It lacks the visibility we really want. It's got a different orientation of, hey, the way we do tracing is not necessarily how we've thought it would end up. And then ownership, going back to the service owners not having the control and ownership that they want. Next slide. So what does this all lead to? Tracing has become the high promise, high effort, low value story, and it's failed to be adopted.
Yeah, it's obviously where we don't want this. Everyone puts in a lot of effort. Everyone's expecting a lot from it. And I think we intrinsically know that tracing should be able to solve these problems, but we're getting to this point where we've made these investments and we've put these tools in place and we're not really getting the outcomes that we want. And it's starting to get worse, particularly as more and more organizations adopt these microservice architectures on top of containerized infrastructure.
Cody, let's go ahead and launch the first poll. So the question is, do you have or anticipate having an adoption problem with distributed tracing tools? 5 is you completely agree. 3 is neutral. 1 is you completely disagree. And then NA is you don't have a tool. The reason we want to know this information is we really want to make sure that we understand what's going on from your perspective, so we can also tailor this content as we go throughout the webinar towards what you're experiencing as a user, or even if you haven't adopted distributed tracing, knowing that you haven't adopted distributed tracing yet.
Yeah, particularly thinking from an adoption perspective. Adoption isn't just, hey, I have 1 or 2 people who can use distributed tracing successfully in my environment, but do I have every engineer able to use distributed tracing in the same way that I have every engineer receiving alerts or able to load dashboards about what's happening with their service, or even you're comfortable looking at logs for their service? The adoption essentially has to get one-to-one. So
Right.
it looks like,
Sorry, go ahead.
yeah, it looks like we have roughly a quarter of people currently don't have a tool. So hopefully they're coming here to avoid some of this pain that we're talking about. And then we have a spread from neutral to completely agree in terms of adoption being a problem with these tools. So interesting stuff, but good to see that we definitely don't have any people who are completely disagreeing, although it could have made for some interesting questions if we did. All right, so moving on, I think it's important for us to, yes, we got these problems, and yes, it'd be easy to just sort of like poke holes in what we're doing with distributed tracing today and just sort of throw our hands up. But if we want to move forward and we want to get the outcomes that we all are interested in, which is essentially lower MTTR, better developer efficiency, and essentially getting the value out of these microservices architectures, we really need to think a little bit about, well, why do we want distributed tracing? And then dig a little bit deeper into sort of the problem space, not necessarily the symptoms and how it's manifesting, but what are we trying to solve in the first place? So, the Honest Update Twitter account put out what's become a little bit of an interesting meme about moving from monolith to microservices. But I think it really encapsulates like what is the actual problem that we are trying to solve with microservices, and it contextualizes in that shift, right? We move from monolith to microservices, but then the tongue-in-cheek approach is that we created these incidents where everything's sort of like a murder mystery. For anyone who's played Clue or maybe watched that movie, is you're digging through and having to sift through every single suspect and follow these red herrings and sift through a bunch of clues. It's ultimately not the clean, simple incident resolution pathway that we'd like. So if we think about the difference between a monolith and microservices, so there's nothing inherently wrong with monoliths. There's nothing inherently wrong with microservices. We're talking ultimately about technical architectures. But the important thing to dig into is that how does this impact people? Because ultimately, these problems in terms of resolving incidents and everything like that, until we're fully operated by Skynet, is how are people interacting with this technology, and how are people able to make accurate decisions and take the right course of action. So with the monolith, you had a team of developers, and the developers essentially knew everything that was going on across the entire application. And that was fine when we had relatively simple applications, but particularly as we scaled up in today's world of web scale applications and always on SaaS delivery, that started to get kind of problematic, because for every engineer to understand everything, it was a lot of information to hold in one place. And ultimately, it meant that every engineer potentially needed to interact with and coordinate with every other engineer as they made changes in the code base. And ultimately, this was slowing down innovation. The whole purpose behind microservices is so that you can chunk down the scope and context of what an individual developer or even team of developers is working on, and they can be more focused on what's in front of them and operate and iterate faster than having to consider what every other developer and every other part of the application or system ultimately needs from them. So a way to visualize this is ultimately the monolith, bound together and operates as one cohesive whole. But then the microservices, we have these sort of splits of perspective. And the whole purpose was for us to innovate faster. And I don't know about you, but innovation software has driven a lot of improvements in my life, both professionally and personally. So I think it's a valid goal, but then we have to think about maybe some of the downsides. So again, the upside was we can iterate faster, we can have this potentially competitive differentiation, we can have many, many developers working on a system that don't need to know everything about what every other developer is doing, which is great when everything is going well and we're building new services and innovating. But it starts to break down, when you think about it, when things go wrong. So a little bit of a visual comparison between what we thought we would get in terms of, well, these little teams, they can operate independently, they can collaborate when they need to, and they only need the context, the very limited context that they have around their individual services. So you can think of these individual teams and their little fighter jets moving as some sort of cohesive whole from the outside, even though independently they're making their own decisions and they're able to be more effective both individually and together. But in reality, what we did is we created even more silos. And they're big and they're clustered together, but you can't really branch between them accurately. And particularly when things are wrong from the outside, it's a case of, well, which silo do we need to go and break down? And the way it generally manifests itself is that during an incident or some sort of investigation that spans the context of lots of different microservices, you just get lots and lots of engineers on the call, which ultimately is very, very wasteful. So really, what now? What if we think about what we wanted from microservices, and then we acknowledge that we have these problems around adoption and pain as evidenced by the responses to the poll, really how do we take this forward? Is it a case of distributed tracing is sort of just thrown out the window? Do we replace it with something else? Well, if we're going to go down this pathway, I think ultimately we can find that distributed tracing just needs to be applied differently. And we need to be realistic about what we're doing with it. And we can't just have it out there as a silo itself. It needs to be properly integrated and thought through exactly what we're doing. Before we get to that, we have a second poll. So from the perspective of drilling a little bit deeper into the kinds of pain that we're talking about, during a severe incident, do you have confidence that distributed tracing is going to help you and your team more quickly discover the source of the problem? So if you're very confident, it'll be a 5. If you currently don't have a tool, then obviously select that. And if you completely disagree, then select 1. So inverting some of the choices this time around, but as you've adopted microservices, and we know that, I guess, somewhere around 3/4 of you have, do you have confidence that the tracing that you do have is going to help you more quickly discover the source of the problem? So slightly different perspective on the question that we asked. Maybe, let's see. So right now we have a lot of people who agree that distributed tracing is going to help them more quickly discover the source of the problem. And this is exactly what we're really expecting to see, right? It's like the potential of distributed tracing to help you solve problems should be very, very high. And we're seeing, 50% agree or completely agree. We still have a significant portion who don't have at all. And then we definitely have some people who are a little concerned, right? They disagree or completely disagree. And there's actually a meaningful population there who are neutral. They have yet to be convinced one way or the other. So if we think about groups 5, 4, and 3, this is really the group that have distributed tracing, are hoping that it's going to deliver those outcomes, and I'm assuming probably want to get a little bit closer to more quickly discovering the source of the problems during those severe incidents. Thanks for participating. All right, so moving on. So if we think about the microservices environment, we think about that complexity, maybe we can boil it down to really just that distributed tracing should really allow you to understand where your problems exist. And if we start from there, then we can maybe have some realistic expectations and an achievable goal that we can really narrow our scope down into, and at least initially, so that we can make better use of the features and functions that are floating out there. So if you think about your workflows and that old style where, well, we just had distributed tracing floating out to the side. If we think about today, what do you generally do when you have an incident? You have an alert, and oftentimes you want to understand the scope and impact of that alert. You typically will look at some sort of dashboard, and there's definitely been a shift in today's world to move to things like SLOs, and SLOs that are definitely business impacting. So rather than just having alerts go off willy-nilly and just deal with every alert under the sun, you want to focus on alerts that are impacting the business, that give you context. But once you understand that context, you need to maybe do explorations, right? You need to understand things like potentially which customers are affected, and you need to be able to drill down a little bit deeper and understand the context of what you're doing. From there, though, oftentimes people would hop into logs directly or APM, or even just look at a whole bunch of other service dashboards and try to pattern match which source matched up to the problem that you were seeing. And this is where we can inject distributed tracing to help us understand the where. And if we're purposeful about these workflows and purposeful about the outcomes, then we can drive towards a sort of better environment where we have the greater adoption and outcomes that we're all hoping for. So distributed tracing can not only help us understand the where, but then give us a jumping off point and say, well, it's not necessarily going to give us the root cause, but it can show us, hey, if you're concerned about the errors for a particular service, then maybe the logging destination is the one that you need to go to. If you're worried about the performance of your old monolith, and that's the thing that distributed tracing points you to, maybe you hop over into your APM tool. And maybe if you get signal that something weird is happening with the underlying infrastructure that's powering the request, maybe that's where you would hop over to metrics. But it's not just a one-way analysis. You're also wanting to feed from distributed tracing and the context you get back in to improve things over time. So maybe with distributed tracing, you can get a better sense of like which things are actually important to alert on. You have a high-level business problem, but maybe you need to alert on this narrow use case of particular customers who are having issues. And there's also the ability for you to refine the insights you have on dashboards. So you're spending maybe less time in a purely distributed tracing world, and you're able to hybridize it. So maybe on your dashboard, you can understand immediately which dependencies actually are causing you errors. So by turning this into a loop of improvement, distributed tracing is not just useful in the navigation to the where, but it also improves your detection and contextualization of issues over time. One way to really make this explicit in terms of features, now that we've broken out the workflow, is to then say, well, this is how, in the case of Chronosphere, we're actually pulling these things together. So Metrics are the lifeblood of many cloud-native organizations, particularly those who have adopted Kubernetes. It's obviously very high adoption of things like Prometheus to understand what's happening with your containers and infrastructure, as well as the high-level signals of what's happening with your applications and potentially also your business. So you have your alerting, you want to have your visualization. You need to have out-of-the-box user experience and dashboards that allow you to understand what's happening with your services. But linking from metrics to tracing starts to bridge that gap so that you're not just spinning up a new tab and opening up tracing in its own individualized tool. Instead, you're able to jump from the context of what's happening in your dashboards, maybe the problems that you're seeing, and then dig into more tool-assisted trace analysis. And tool-assisted is really important because you don't just want to do the equivalent of regexing through millions or billions of spans. You want to have insights surfaced up to you so that it's approachable, even with this linking. So once you click in, you're able to get valuable insights straight away and guidance. But then you also need to be able to take information from the traces, not just the individual waterfall views, but potentially data from hundreds, thousands, millions of traces, aggregate that together, and then start putting that back into alerting or dashboards. So you can start building things like better SLOs, and you can start modifying your view of what the service owner sees when they hop to those dashboards as the first point after they start to get those alerts. And this is how we can actually impact MTTR and MTTD and broaden the adoption across all of our engineering organizations and get that usability up. So if you recall, there are also other points on the issues that we were talking about in terms of the tooling and just general usage of distributed tracing. One of the big ones is around sampling and data quality. Exemplars are a very common topic and way that people get their foot in the door of having tracing implemented in their environments. And exemplars essentially are a form of sampling, but it can get a lot more insidious than that. And we need to really dig into sort of the impacts that this can have. So importantly, as you're approaching sampling, it's not to say all sampling is bad, but you need to be aware of the impacts that it's having and make the right decisions for your team and your wider engineering organization. And that's important because there's no one size fits all. There are some organizations that sampling is going to be very, very key to adopting tracing, and there'll be others where sampling is really just not going to be appropriate. So we start left to right. Fitting your data to your use case is critically important. If you were to take the population of data points on the left and you say, okay, well, I have these 3 exemplars or 3 samples. Oh, there's 2 white ones and 1 red one. Maybe the red one is something that's alerting. You get a very incomplete picture of exactly what's happening. The population on the right gives you a much better sense of sort of the ratios between the requests in white that are presumably okay, and the ones in red, which are erroring. And maybe there's some sort of weird pattern also happening in the ones in orange. Maybe it's a population related to paying users or very, very valuable customers. And not getting all of that information when you have a breadth of use cases or a breadth of types of data or issues can be very problematic in you actually being able to resolve your problems. And at that point, again, you're going to revert to using metrics, logs, or APM, and that's going to lead to a giant erosion of the confidence in your tracing tool when you need it the most. It's also important that any sampling that you do, you have control over. You can't just rely on sort of randomized or black box algorithmic sampling. You need to be able to tweak this and understand the impact that it's having on your data set. So for example, if you use the populations again, if you know for sure that you have the ability to capture red, orange, and yellow samples, maybe that's all that you need. Or if you need to capture all of them, then you need to tweak that for maybe one particular service. But if it's a black box and you can't modify the way sampling is done with your tracing, then it's ultimately going to lead you down the pathway of breaking the value of that data set. And then ultimately, you should also be focused on making sure that you're not making your sampling decisions purely based off cost. Because if you are taking the approach of, well, every customer is important to me, but I can't afford to save every single trace to diagnose problems, then you're really on a collision course between sort of the cost of your observability tooling and the outcomes that observability tooling is trying to achieve for you. So at that point, regardless of whether you're using a homegrown solution, open source, or a vendor solution, it's probably time to take a look at something that's maybe more cost effective so that you're not compromising your data set just based off cost. Okay, I want to walk through a brief demo now, just showing you just a little bit of how, particularly on the workflow side of things, Chronosphere is handling this. So 1 second while I just swap over.
In the meantime, while Ian's getting that set up, if you have any questions, feel free to put them in the chat or the Q&A. We'd be happy to answer them.
Cool. All right. So illustrating a little bit of going from that alerting workflow and drilling in. So you can see here that I have an alert up in Chronosphere for my order service and a spike in errors. And coming down here, we can see obviously what's happening with the errors, and we can see sort of the different time series that we're evaluating. And delivered in the alert is an annotation that links us over to a dashboard that's going to help us investigate what's going on. All right, so as we flip over to this tab, here's an out-of-the-box example of something that's pre-generated in Chronosphere using, in this case, tracing data, logging data, and then infrastructure data for this particular service, the list order service. We can see here that we have a spike in requests, we have a spike in errors, and we also have a spike in P99 duration. And this is the kind of thing that we want to go and drill into and better understand. Now, lots of metrics dashboards in particular have very little interaction with them. And this is something that we think you can really sort of avoid and get past, because it's a really good way of understanding what's happening and driving context with your investigation. So I'm very curious about what happened at this point in time to see this spike, very significant in P99 duration in my order service, and particularly for my list orders. So at this point, I want to go and query my traces. So I'm going to flip over to this tab, and this is where we've gone from metric dashboard out of the box into specific tool-assisted trace analysis. You can see here that we're analyzing a whole bunch of data that's happening with our traces. We've grabbed the context of everything that we've seen. We've seen a particular time frame, and from the metrics dashboard, the context we've brought over is the particular service, as well as the endpoint, and the fact that we're looking for things that are particularly slow. So all of this means that as a user, I haven't had to go and put these filters or queries into my search. Instead, it's all been brought over for me. And I'm looking now at those things that are specifically slow and problematic for my service. Now, I can compare to maybe immediately before and see sort of what the difference is between the two populations. And it's interesting to see that the request rate for this fetch item, as well as for my MySQL queries, have really skyrocketed in the time frame that I'm starting to see this error. We also have a very significant set of errors in the portal service and the order service. Now, this is all very interesting, but I still need some orientation as to what I'm looking at. Maybe I don't know the dependencies. Maybe I don't know if there are any upstream things that I'm a dependency of. So the topology view is going to be that next place to go, where we can take many requests of traces and we can get a better understanding of exactly what's happening. So we can see here, we're looking at a service level and we're seeing the different requests. And there's definitely been a giant explosion in the number of requests in the ordering service, as well down to the MySQL database. We can also say, well, I actually want to take a look at the operation level. And we can see here that the portal service and list orders is calling list orders on the ordering service. And then that is leading to a very significant number of calls into fetch item, as well as the MySQL database. So this looks suspiciously like maybe we rolled something out and we suddenly started doing a lot more calls to the auto service fetch item, as well as the database itself. And we're just able to see that just sort of automatically in this analysis of everything that's going on across many traces in our data set. And this sort of lines up with what we're seeing. So it looks like essentially we're generating a bunch of new requests. They're taking a really long time. We may be causing a timeout, and that's presenting itself as errors and slowness to our end user. Now, of course, we can go and validate this. We can go and take a look at maybe one particular slow trace. Let's take a look at this one that's taking 24 seconds. Open this up. And you can see here that we have this trace that has many, many spans in it, over 4,000 spans. And we have this repeating pattern of list orders, which is taking a long time and is an error, is constantly calling the database as well as calling fetch item. And it appears to be doing all of this stuff in sequence rather than in parallel. So it looks like we basically generate an N+1 issue. Okay, at this point, we can go back to our trace analysis, and we presumably would just roll back our deployment, having found this particular issue. We could have, of course, dug into further logs or metrics, but it seems pretty clear that we have a bad deployment that's generating this N+1 issue. Now, in terms of alerting us on this the next time, and maybe even reducing the amount of investigation that we need to do, we could always create a new metric based off this search. But before we do that, let's go and edit the query. And while we have slow queries happening here, maybe what we want to do is also go and add a filter that says we want to see when we have more than 5 particular requests happening on list orders. And so this would allow us to have a very narrow kind of alert, or maybe even set of metrics that appear on the dashboard. I can quickly show you one that we did earlier. So if I go over to trace metrics here, I can see this particular dashboard element that we're also pre-generated as well. And we can go and take a look at how we've gone and built this out. So you can see here, we have the matching span counts essentially letting us know, and we can go and embed any of those metrics or even the topology view showing us the dependencies and where the errors and services are appearing into any one of our existing dashboards. And in actual fact, I'll show you briefly what this also looks like when you embed it into the purposeful UI that we have here. So you can see here, we have a collection of information about the particular service. We have the team dependencies as well as useful links. We have a list of the errors. We have the key metrics as well as a view of the topology across this environment as well. So all these things, some of them are powered by native metrics, some of them are powered by trace-derived aggregates, but being able to compose this stuff together and make it more accessible for the wider population of engineers is ultimately that goal of getting broader adoption and high utilization of the investments that we've made in trace data. Okay, I'm going to swap back briefly to our slides so that we can wrap up. All right, so summarizing with April. Overall, it's important that we don't just treat tracing as another checkbox and something we just slap onto our existing stack of data and assume that the data is just going to magically become valuable. We really do need to be purposeful and really integrate it with what we're doing so that we can achieve the outcomes that we want. It's important to acknowledge that the poor adoption is really linked a lot to focusing on shiny features rather than thinking about, well, what do we need from distributed tracing and how do we need it to power the outcomes that go hand in hand with a microservices architecture. And particularly with the complexity added by microservices and the siloing effect, where problems exist is really what distributed tracing is very good at answering for you, as illustrated in things like the topology view that I just demonstrated. Adoption is really only going to come if all of your engineers are able to make use of distributed tracing, whether it's in a dashboard with a topology view or a customized trace aggregate metric, or being able to link from those dashboards into the tool-assisted analysis so that we can augment those existing workflows. And then, at least in regards to instrumentation and sampling, it's very important that you're purposeful and making those choices based off your use cases and what your data says about what you need in the organization, rather than being confined by what is accepted by your tools, or in a worst case scenario, ultimately making decisions based off cost. There are some resources, and this will be linked in the slides that will be available to you as well. And I think now we can probably go to any Q&A.
Thanks, Ian. I actually have a question for you, because looking at the poll data, I was like, why do you think about a quarter of our attendees don't have a tool right now?
Yeah, I think the adoption of microservices is something that a lot of engineering organizations are being a little bit cautious about, rightfully so. There are obviously early adopters, some who have seen great advantages to adopting microservices. But as we've talked about, if you adopt microservices and you don't have the right tooling to be able to achieve the outcomes that you want, particularly around incidence observability and performance optimization, then ultimately you could get in a situation where the downsides negate any potential upsides. There are also some group of organizations who have adopted microservices and are struggling right now because they are still using metrics and logs and don't know how to take those next steps with distributed tracing. For those people, I definitely encourage you to make use of OpenTelemetry and even maybe start using some of the open source tools, even to just get a basic idea of what your traces look like representing the requests as you start to build out your microservices. I definitely wouldn't encourage anyone to hold back on adopting distributed tracing when you have the pain of moving to microservices, but you do need to hopefully take some lessons from what we've talked about today on what the right way is and how to select the best tools and really roll out that instrumentation more broadly.
Cool. Thanks, Ian. The next question I was thinking of from our second poll was, we talked about what is the confidence someone would have in a severe incident, and we had a wide range of responses. And so why do you think that is? Because I know from your experience, Ian, you've seen has not been as helpful to have distributed tracing, but some people clearly have found it effective.
Yeah, I think it's a spectrum. It's, there's a difference between having wide adoption and having confidence distributed tracing will help in an incident. But I think one of the things you have to think about is, what does it cost you to get those outcomes? To be more specific, I imagine that there's a fair number of engineers and attendees on the call who are thinking, well, I know distributed tracing was used in that last incident to help solve a problem, but how was it used to solve that problem? Did, for example, we have one power user who sort of did a heroic effort by himself or herself to solve the issue using maybe suboptimal distributed tracing capabilities? Or was it really a scenario where any engineer was able to go and solve the problem, and they were able to solve the problem without bringing a lot of additional people onto the call? And so that to me is that question of, what does it cost you? It's not necessarily how much money we're paying per incident, but what did it cost the organization? How many people did we have attend the war room? And did we have to disrupt the work of particularly senior engineers? And were they the ones who had to use tools that ultimately aren't utilized across the organization? So if you have confidence distributed tracing can solve your instance, it's not necessarily any disagreement. I definitely think distributed tracing is very critical to solving incidents, particularly in microservice environments. But it's that element of, well, if you have a confidence that it's going to help you, but on the other hand, you have very low adoption, then it's probably costing you potentially your most innovative engineers and burning a lot of unnecessary engineering time across the organization every time you have one of those incidents.
Thanks for that feedback, Ian. My last question is, talk more about when is it a good idea to sample data versus not. You talked about how, there's the black box method of sampling where you're relying on the vendor, and then there's other ways. For example, with Chronosphere, we can actually set how you want to sample. So talk a little more about that.
Yeah, so sampling really needs to be aligned with your use cases. The example I gave of sort of the small box and the large box, the different populations of data, is really a key example of this. Where if, for example, you care about every single individual customer and every single individual user because maybe you are a relatively low transaction, a very high value sort of engineering shop. So maybe you're doing payment processing. That's oftentimes a good example where each transaction could be worth $5, but it also could be worth maybe $1 million. Those are scenarios where you can't just aggressively sample and say, okay, I'm going to sample 1 in every 100 requests, because that means that in the 99 requests that you are not sampling, if you have issues where errors are not being captured and you have $1 million customer who comes to you and says, what happened here? You are going to run into issues where sampling is really just no longer a viable option. And if you are trapped in that sampling decision because of cost reasons or because the tool that you're using only can handle that level of load, then it's a bad situation. It's one where you've basically made choices out of convenience or because of cost, and that's now starting to compromise your observability and compromise the outcomes you want from your observability with your business.
Thanks, Ian. I would just, more of a general question for you. What did you think of all those responses in the polls? I had you do some commentary on those specific data, on the data points, but I'm curious if you got any other commentary besides on the polls or just in general that you wanted to add.
No, I think what's interesting is that people still have high hopes for distributed tracing. I do as well, despite the problems that we've talked about. The last thing that I'd want is for people to go, well, I have zero confidence that distributed tracing can do anything at any point. We've moved on to something else, or we're putting all our investments solely in trying to expand our metrics and our logs. I think you can try and solve a lot of problems with metrics and logs and even APM, but it's going to be more effective. It's use the right tool for the job, particularly for that where situation. I know organizations that, hey, users can't log in. There are 15 services that we believe are associated with login. Let's get every single person from every single one of those teams on a call. Let's look at everyone's dashboard and let's try and figure out who has actually got the source of errors. In a microservices environment, it's very hard to understand where your errors are actually starting from. And so having that hope and belief that distributed tracing can solve problems is still critically important. But also that acknowledgement that adoption is not there. I think it's just further proof that what we've been talking about with the industry is definitely seen by the population of attendees that we have here today.
Cool. Thank you, Ian. I don't see any other questions coming in right now. So Cody, I'm going to hand it back to you to close us out.
Sure, April. Thank you so much. And Ian, thank you for all those answers as well. So to our audience, we do still have a few minutes here for Q&A set aside. But in the meantime, I'll go ahead and remind everyone that this session was recorded. So following this program, you'll receive an email with a link to access this recording on demand, or you can find it living on the DevOps website at devops.com/webinars. And then just be sure to look in the on-demand section. You'll find it waiting for you. I'll also take this time to give away our 4 $25 Amazon gift cards. So our first winner is Macmillan G. Our second winner is Homeyar W. Our third winner is Maria M. And our fourth and final winner is Craig T. So to our 4 winners, congratulations. Do please keep an eye on your email inbox to claim that gift card. But if you don't happen to see that email, do please check your spam folder. All right. So we have not received any more questions. So Ian, April, I do want to give you to the floor just one more time in case there was anything you wanted to leave our audience with before we take ourselves off the air.
I can go first, Ian. I would say as I've learned more about distributed tracing over the last year, there's definitely been a challenge in this space of how do you make sure adoption happens. Ian really touched on it a lot, but as I've grown more aware of the challenges and how engineering minded things can be, coming from my perspective, having a different mindset towards workflows is definitely helpful, and thinking about it from that perspective rather than, okay, how do we just get more data?
Yeah, and I guess the thing that I would say is that if anyone is curious, wherever you are in your journey with microservices or distributed tracing, please reach out to us, chronosphere.io. More than happy to have a conversation, and we're definitely going to be at a bunch more conferences coming up. So looking forward to meeting people out there.
Perfect. Thank you. Thank you both so much. I'd like to thank Chronosphere for sponsoring today's program. And to our audience, we really appreciate you spending the last 50 or so minutes with us. We do just ask for one extra moment of your time for a survey that will pop up on your screen as soon as we close out. But otherwise, we do hope to see everyone at an upcoming TechStrong Learning program. Have a great rest of your day. And April, Ian, thank you both so much for joining me today.
Thanks, Cody. Thanks, April.